The bounded region shown represents the base of a solid. Find the volume of the solid based on the given cross-section. Set up the integrals and evaluate. All right, so we're doing a cross-section of a square, and we're doing this perpendicular to the x-axis. So this is what we need to do, okay? Here are my boundaries. 0, I don't know. We've got y equals 2. We've got the cube root of x. All right, so by doing cross sections of squares, we are creating a bunch of squares, right, all throughout this whole thing. And what we're going to do is we care about finding the area of these squares. Oh, that's such a bad picture. We're finding the area of these squares so that we can integrate that to find our volume. All right, now what I have to focus on is what are the side lengths of each squares? Well, if this top equation is 2 and the bottom equation is root x, then each side length is going to be 2 minus root x. And so if each side length is 2 minus root x, then to find the area of a square, we square the sides. So the area is going to be, a of x we'll call it, is going to be 2 minus root x squared. Okay? So what I need to do now is I need to find out what that limit is right there. The way that I can find out what that limit is right there is I could take my two equations down here and set them equal to each other. The square root of x equals 2. In order to get root x all by itself, I'm going to square it. X equals 4, and these guys intersect at 4. So the integral that I'm going to set up is going to be the integral from 0 right here to 4 of 2 minus the square root of x squared dx. Now, before I even consider integrating, I want to FOIL that out. I want to use a perfect square trinomial and clean that up. So that's going to look like 4 minus 4 root x plus x. Oh, this is going to be terrible. This is going to be terrible. This is going to be terrible. This is going to be so bad. Let's rewrite this out between 0 and 4. 4 minus 4x to the 1/2 plus x dx, and wish me luck. All right, so breathe in, breathe out. We have the integral of 4, which is 4x, okay? We have the integral of this guy, which is going to be 4 over 3/2 x to the 3/2 plus x squared. Nope, 1/2 x squared with limits at 0 and 4. So let's clean this up a little bit more. 4x. This is going to be, if I flip this and multiply, this is going to be 8 over 3, so 8/3, so minus 8/3 x to the 3/2 plus 1/2 x squared. My limits are, oh, squared's in the wrong spot. My limits are going to still be 0 and 4. Now the nice thing about this guy is, I guess, if there's a positive anywhere, here's a light at the end of the tunnel. Okay, when I plug stuff in, I'm going to have 4 times 4, no big deal. Okay, no big deal. Minus 8/3 times 4 to the 3/2, that's very unpleasant, plus 1/2 4 squared. If I were to do the minus and then do the same thing and plug in 0, it's all going to become 0. So we'll just say minus 0 and save some time. Okay, u becomes 16. Minus 8/3. If I square 4, I get 16. And the cube root of 16 is going to be 2 root 2. No, it's not. 2 cube root of 2. Yeah, there's nothing I can do about that. Oh, no, I take it back. I'm cubing 4, which is 64. And then the square root of 64 is 8, so that's not that bad. I apologize. Plus 1/2 of 4 squared is going to be 1/2 of 8. Or 16, which is 8. So u becomes 16 minus 64 over 3 plus 8, which is going to be 24 plus 64 over 3 Multiply the top and the bottom by 3, giving you 72 thirds plus 64 thirds. And that's going to end up being 156 thirds. Gross. So definitely not a pretty problem at all. Not by any stretch of the imagination, but we did it.